Good evening, everybody. Please, someone should confirm if they can hear me.
We can hear you.
Okay. Good evening, everybody. You're welcome to this virtual technical session on drilling program and monitoring, which is the key to a successful oil and gas operations. My name is Tyrese Stabel, and I'll be your moderator for today's discussion. So before we continue, I would like the students that are here to just post on their WhatsApp platform that we've started, and others can as well send down the link for others to join. Thank you very much. Please do that quickly so you don't miss out on any important information. Thank you very much. Okay, you're welcome once again. We'll start this meeting with a safety brief, which will be taken by the General Secretary of IADC PTI chapter, Mr. Promise Ifeluni. Please, Mr. Promise Ifeluni, take over and give us some safety brief.
Okay, good evening, everyone. Please confirm you can hear me.
Yes, we can hear you.
Okay, I want to welcome everyone to this wonderful technical section. And as you know, in whatever we do, safety should be first and always. So to begin this section, we want to take and remind ourselves of some safety tips that will guide us throughout this meeting. And like you know, this is an environment or time that the network might not be favorable, but let's try as much as possible to stay within a good location where we can have a good network connections. And for those of us that will be using earphone or earpiece, let's ensure that it's not too loud that we can't hear something or persons from our environment. And you should also observe a good sitting posture. And maybe after sitting for a while, you can stand up and stretch your body, and always make sure that you mute your mic when you are not speaking, and you use the chat box for question or comment, or you can use the hand emoji to raise up your hand in case you want to speak. And I think you should also pay attention to your locations. Make sure you are at alert in case of any information or anything around you. I think with that, we can go ahead with the section. Thank you very much and welcome again to this wonderful technical section.
Thank you, Mr. Promise, for that wonderful safety brief. So quickly, we'll be going straight to the opening remarks that will be taken by Mr. Kalugo Israel. Please, Mr. Israel, over to you for the opening remarks. Mr. Israel, please, can you hear me? Mr. Israel. Okay, it seems he's having a network glitch. So I don't know if anybody will be taking that session. Okay, since it's not.
All right. Can we hear me?
Yes, we can hear you.
All right. So I'll be taking the opening remark on his behalf. My name is Oyibo Godson, the president of SPE PTI, and I want to appreciate everyone for pushing for. So this topic is very essential in the oil and gas industry, as it connotes what we need to do as every engineer in whenever you're in the oil field. we need to set up our drilling program and monitor it to ensure successful oil and gas operation. And I'm sure Mr. Engineer Ugo will take us through this and give us deeper understanding. I want to urge every one of us to make sure we are with a pen or we pay attention and avoid distractions and ask questions. Questions are very, very essential. And finally, I want to once again say thank you everybody for joining in, and please have a wonderful session.
Okay, thank you, Mr. President, for that remarkable opening remarks. So next on the agenda is icebreaker session. We'll be having our icebreaker session, which should be taken by Mr. Victor Obina, the Vice Chairman of IEDC PTI chapter. So please, Mr. Vilton, over to you.
Okay, thank you so much. This is Crystal Bell, our esteemed IEDC treasurer. Please, can anyone indicate if you can hear me? I need to get
Yes,
the
we can hear
feedback.
you.
We can hear you,
We
sir.
can hear you. Mr. Vilton, please, are you still with us? Please, we want feedback from you.
Hello?
Yeah,
Can
we
you
can
hear
hear
me?
you now.
I hear you.
Okay,
Yeah, we
sorry
can
for
hear you.
so the first question for the icebreaker. I'm having some technical glitch on my end. I apologize for that. Okay, thank you so much. The technical team, I appreciate. The first says, if you are leading a drilling operation in a remote area, what's the first thing you'd want to double check before starting the rig? Now, we have some options. The first says the color of the company logo. The second says the playlist for the crew. The third option, option C, says the drilling program and well plan. Option D says the number of coffee cups in the control room. I would like someone to briefly respond to that if you have an answer to it. Okay, yes, I have from Promise Felony. Thank you so much for your response. C, and that is actually the correct answer to that question. The first thing we should do if we are to lead a drilling operation is to go through the drilling program and well plan. Very, very important. Okay, moving on to the next one. Thank you. The correct answer is C. We already have Hendrix. Thank you for your feedback. But the correct answer to that question is option C, the drilling program and well plan. It has been highlighted. Moving on, the next icebreaker, the next question in the icebreaker session will have, what do you think will be more dangerous to an oil operation? Poor planning or poor monitoring? I'll be taking feedbacks in the next 3 to 5 seconds. Please kindly react to this question on the icebreaker session. Okay, I'm yet to get a response on it. C, I'm getting from Hendrix. C, option C. Okay. I'm getting from Jesugari. Thank you so much. Both. Okay. Can we have the display back? Now, okay. So for that particular question, the options are both are correct. Both are correct. Yes. The next one, moving on, we say, what do you think would be more dangerous? Now okay, what do you think would be more dangerous to an oil operation? Okay, we've gone past that. Yes, this option C is correct. Both are equally dangerous. Okay. So moving on, we say, imagine you are designing a drilling program. What's one thing you absolutely wouldn't forget to include? What's that essential key thing you would not forget to include? The first option A says a welcome message to the crew. Option B says the name of the drill site. Option C, casing and more design details. I think I'm already getting responses from the audience. Yes, I'm having from Ukemide C, option C. Adelete, thank you so much, option C. If any promise, thank you so much, option C. That goes to show we are quite enlightened on the subject matter, which is absolutely correct. The correct answer to that question is option C, casing and more program details. It has been highlighted for you. Hendrix is quoting option A, which unfortunately is wrong for that question. I appreciate your responses. Now, moving on to the fourth question, the icebreaker session. Say, have you ever been in a situation where a small oversight caused a big problem? How might that affect in oil and gas drilling? A, option A, it probably wouldn't matter. Oil operations are robust. Option B, oversight can lead to safety hazard, blowouts, or cost overruns. Option C, oversight just slows things down a bit. I'm already getting responses. Option B, B from Victory, PTI Hendrix, so many responses. Now, the last option says you can always fix it later without much consequence. Okay, now let's look on to the one that is correct. Being in a situation where a small oversight causes a problem, how might that apply in oil and gas drilling? Now, absolutely correct. Option B is quite correct. Oversight can lead to safety hazards, blowouts, or cost overruns. Thank you so much. That was absolutely correct. For the people that responded to option B, that is totally correct. Now, I think this is a fixed question. Who here knows what a drilling mud logger does and why that role is so crucial? This is the role of a mud logger. Why is it crucial? I'm here to read out the options. A, deliver food to the rig, they manage the rig's playlist, and so on. I think that is my time for today. Now, option C is absolutely correct. They monitor drilling fluids and detect formation changes. Thank you so much for everyone that participated in this icebreaker session. It was quite entertaining and educational as well. I really appreciate your feedbacks. Thank you so much to the moderator, Christabel, as I hand over to you. Thank you so much.
Okay, thank you, Mr. Vice Chairman, for this wonderful icebreaker session. It was really engaging. And thank you everybody for your responses. So quickly, we're going to be introducing our guest speaker. We're having our guest speaker with us. We should be taken by the chairman of IADC PTI chapter, Mr. Solomon. Please, Mr. Solomon, over to you.
Good evening. Please, can you all hear me?
Yes, we can hear
Yeah,
you.
you can hear me, sir.
Okay. Okay. To kick off things, Engineer Alezi Ugochukwu is an highly skilled petroleum engineer with a solid academic background and progressive industry experience. Engineer Alezi holds a first degree in petroleum engineering from the University of Port Harcourt and a second degree in petroleum engineering and project management from IPS. Its professional experience spans across drilling and well operations, beginning as a mud engineer with Hamilton Technology Limited for 3 years, subsequently served as a petroleum engineer with Seplat JV Nigeria Exploration and Production Limited for a year, and he has 3 years of hands-on experience as a well site drilling engineer with NEPL and currently serves as a well design engineer with OMA 30 Asset Management Team at the Nigerian Exploration and Production Limited. Okay, that's all. We are so amazed about his portfolio. So that's all for me. Over to you, moderator.
Okay, thank you very much, Mr. Chairman, for that introduction. So we'll be having a lecture, which is the basic reason why we are here. We'll be taking a lecture, which will be taken by our guest speaker, Mr. Engineer Alizi Ugochukwu. So, sir, please, over to you for your lecture. Mr. Ugochukwu, please, can you hear us?
All right. I think he's having an issue returning the call, so let's just give him a few moments, please.
So please, while we are waiting for Engineer Ugochukwu, I believe we are all enjoying this session. Please, you can drop a reaction if you are. You can do that through the chat box. If you're enjoying yourself, just please give us a reaction. Thank you very much. Before Mr. Ugochukwu will get back to us. Thank you very much. I can see some reactions. Some person are asking for refreshment. This is an online meeting. Sorry, there's no refreshment. You are going to be refreshed from the things you are going to learn and gain from the meeting. Let's keep the reaction going. Thank you very much.
Okay, well, while we are waiting for the people here, said he can actually hear us, but he's having a bit of challenge trying to his mic. So I think in just a bit to refresh and get back to us on this lecture. So just please invite your friends, your colleagues, your roommates. If they don't have data, please can send them start sending them data right now so they can join us.
Please, President, can you please come again? You were not clear.
He said while we are waiting for Mr. Ugochukwu, others can just send out the link for people to join. Send it to your friends, your classmates for them to join. Post it on your WhatsApp classroom as well for them to join.
Okay, thank you. Appreciate.
So please, if you are not with your pen and your jotter, kindly do so before he begins his lecture, because there will be a Q&A session after the lecture. So please just get ready to learn and keep your question after the lecture for the Q&A session. Thank you very much.
Hello, Christabel. Please confirm you can hear me, or can anyone hear me at all?
Yes, we can hear you.
Okay, sorry, I sincerely apologize. My system was misbehaving with its input, but the output was fine. I could hear everyone. Apologies, please. Hope we've not lost anyone out. Okay, so my own answer, I feel the first one, or will I say I have my own reservation? Well, planning and program is not the first. It's for me to have good coffee so that I'll see road clearly in the night. So that's my own first answer for the icebreaker. But well done well done, kudos to the team for a wonderful icebreaker. And just a little observation, the mod logger's responsibility is not monitoring of the drilling fluids, but more or less the cuttings. They monitor the curtains, and then yes, it's good when you get to the rig. Please greet the crew. Haba, you guys are too serious, but great one. So without much, I'll just quickly try to share my slides. Please confirm when my slide becomes visible. Please, Christabel, you need to enable me to share my screen. They said host disabled participants screen sharing. I don't know if you can enable that for me, please.
Okay, I'll do that now.
I think you
So I've done
can
that,
share.
so you can share your screen now. Yeah.
Okay. Oh my God, Zoom is a lot different from Teams, but let's see how it goes. Please let me know when you can see my slides, please.
Yeah, we can see it now.
Okay, confirm is in display mode.
It is.
All right. So good evening, everyone. Good evening. I see we have two different associations. We have both SPE and IADC team. So good evening, everyone, and thank you for joining us today in this wonderful lecture we'll be having today. I don't know most of yours background, but I believe you should have a bit of knowledge in will I say well engineering or drilling of oil and gas. So because some terminology, um, I just hope I'll break it down anyway to the barest one I can. So my name is Alias Gochiku, and today I'll be speaking on. Sorry, I'm trying to minimize a lot of things blocking my screen. Okay, minimize. Okay, and today we'll be talking about drilling program and monitoring, a key to successful oil and gas drilling operations. So this is my outline. We'll start by looking at what is drilling, the various types of wells we have, the process involved in drilling before we head down to the drilling program, which is the primary objective of this particular meeting or lecture series. And then we'll look at the drilling operations and monitoring. So I would like to ask, there will be some part of interaction. So I'll ask, please, if I'll just want to hear from at least two persons, what do we understand by drilling? So I can't really see anyone raising their hands. So Christabel, just help me to coordinate that. Anyone that raises their hands should please just help and define what they understand by drilling, please.
Okay, all right, sir. Please, if you have an answer, you can just raise your hand or
I'm seeing
unmute your
Hendrix.
mic.
Yeah, please just go ahead and
Hendrix,
unmute your mic.
please
Okay.
unmute your mic.
Me.
Is it me? I can't hear you, Hendrix. Okay.
Hello, can you hear me?
Yes, you can go ahead.
Yes.
Okay, thank you very much. I would say drilling is application of science and technology in creating a usable hole on the earth core to make contact or to create communication between the surface and the subsurface.
Ah.
I think
Wow.
contacting hydrocarbon. Thank you.
That's beautiful. That's beautiful. Who else? That's wonderful. Brilliant.
Okay.
Okay, Joe, you can go ahead.
Okay, so drilling is making a pathway for the hydrocarbon in the subsurface using a technology in a timely, safe, and efficient manner.
You guys know all this already, so that is wonderful. So in summary, most of us, whenever we hear drilling, we just think of the big oil and gas, yes, which is correct. But drilling is as simple as what we do in our borehole, how we assess, like the first person said, I think it's Joe, how we assess what is in the subsurface. Then in terms of the borehole, the subsurface, what is there that we're trying to assess is what water. So your ability to make a hole to assess the resource that is in the subsurface. But for oil and gas, drilling now refers to our ability to, like the second speaker said, to target the reservoir rock and assess the hydrocarbon that is in the subsurface, creating a conduit for it to come to the surface. So you guys are both right. Fantastic. Now, if I may ask, um, we have various types. We have basically three types of wells. Please, if you know the answer, could you just raise your hand and tell us the three types of well you might have heard or know? You can just unmute yourself and talk, please. Is anyone raising the person's hand? Be free. If you're wrong, we'll correct. If you're right, thumbs up. Great work. Okay, Hendrix, go ahead.
Okay. As far as I know, I a production well at a wild cat well, and also we also have a development. I know more than three types of wells, like wild cat well, appraisal well, exploratory well, production well, development well, filter well, deviated well, yeah,
Wonderful.
something like that.
Okay, so some of these categories are subcategories of others. So brilliant. We actually have three types of wells by definition. The first, which is part of what you mentioned, exploration wells. The objective of the exploration wells is mostly so you've carried out seismic operations. You have leads and prospects, and you suspect that there is oil and gas somewhere. The only way for you to confirm if there's oil and gas is by drilling a well. So that first well you drill to confirm if you have oil and gas in that subsurface location that the geologist must have informed you is called the exploration wells. So as way of for them to approve your FDP, field development plans, and as well as for you to make your economic decision if you should site facilities, what size of facilities you should size, how much do you have as per reserves. You have to drill what is known as appraisal wells. Appraisal wells will give you further information about the sand or field or reservoir. There are different terms, yes, that you just discovered. So it helps you to determine the lateral extent, get more properties, more information about the discovered sand. And the final one is called a development well, which we use for production or injection. Production if you're actually producing oil or gas, and injection if you're putting back water for pressure maintenance. So these are the basically three types of well. And for us to achieve drilling these wells, right, we have lots of services that are being run and lots of equipment. Like someone said, it's the science and technology of trying to achieve this. So we have different equipment, but there's one particular key equipment that we must have to enable us to carry out drilling operation, which is the rig. So there are various types of rig, starting from my right to my left. I don't know if this allows for pointer. Just a moment, please. Let me see if Zoom allows for someone to use a pointer. Okay, yes, it allows. So starting from my right to my left, although one is not here, which is meant to be the land rig, we have the barge the swamp badge or the badge or the sit on bottom platform. So basically it's used for swamp locations where water depth ranges from around 5 to 50 meters, after which we have the jackup, which has three legs, which is used for a deeper or shallow offshore zones of 25 to 150 meters, the semi-submersible, down to the drill ship that is used in deep and ultra deep offshore. So these are just the different types of rigs categorized into the offshore and the land locations. So basically, let's look at drilling itself. How does it start? So the very first thing, please confirm you can still hear me, please.
Yes, we can.
Okay, so the very first process you start with for drilling operations is piling of the conductor casing. So if I may ask, can just one person tell me what the person understands by piling? What do you understand by piling? Anyone, please. Should I call Hendrix or should I call Christabel? What do you understand by piling? You must have heard the word, not necessarily for oil and gas. What do you understand by piling?
Okay. Thank you.
Go ahead.
Yeah. Filing is usually done as the first instance while trying to put in your conductor casing. It's usually put down, driven down inside the particular place you are willing to drill. So maybe like a heavy duty hammer or heavy duty machinery to just basically force it down into the subsurface.
Okay, fantastic, fantastic. Let me just break it down. Christabel. Hello,
Can hear
Christabel.
you.
Good.
Yes, I
How
can hear you.
how do you hang your picture frame on the wall? What's the first step if you want to hang your picture frame on the wall? What do you do? You have a
And there
picture.
should be like a hanger at the back of the frame.
Good.
Then a
So that
nail.
hang.
A
Good.
nail.
A nail. The nail. How do you put the
Yes.
nail on the wall? How do you put the nail on the wall?
You have to use a hammer to like insert it into the wall.
Beautiful. And I'm sure a lot of us must have used either for picture frame, calendar, anything. So basically that is how piling is. There's a hammer, then take the conductor casing to be your nail. You use that hammer, you keep hitting the nail, hitting it, hitting it, hitting it until you're either satisfied with where it has gotten to, or the nail will get to a point. If there's a beam in the house, it will not penetrate again. That if you keep forcing it, what will happen? The nail will start to what? Buckle, bend. You get my point? So that is just piling. Piling, if you go to a piling location, they have the piling hammer, they have the crane holding the piling hammer, and the piling hammer will be put inside the conductor casing, and the next thing you'll be hearing is boom, boom, just the same way you hit with your hammer on the nail. It keeps hitting, hitting. By the time a particular joint goes down to the ground, because of how soft the formation is, they'll add another conductor casing and weld them together and pile that one. You keep going until you get to a place that as you keep hitting, before, if you're hitting only one, it would go by 5 meters. By the time you start getting to harder formation, by the time you hit once, it will not even go by up to an inch. So you know that you start getting to a place known as what? Point of refusal. That's POR, point of refusal. So we'll talk much about that later. So after you've piled this conductor casing, which is usually the process for land location, you pile the conductor casing, and conductor casing most times are usually 20-inch to about 36 inches in diameter. The next thing you need to do is to drill the surface hole section. Surface hole section simply means you make up the drill bits. I'm using, like I said, I'll be using some terms, and I believe we might have an idea of these terms I'm using. Please, just take down your notes. If there are anything you don't understand, just ensure you ask question during the question and answer session. So once you make up your bits to the BHA, you then run down through the internal diameter of the conductor casing, the first time that bit touches the formation that's towards the shoe of the conductor casing is called spudding. You just spudded the well, and then you now start with what? Drilling. So you drill that surface hole section. The surface hole section most times is drilled with an environmentally friendly mud, which is usually a water-based mud. Why is this so? Because we have the water aquifer, or the drinking water we take, the water table. So you don't want to contaminate it with oil that will lead to serious environmental issues. So you use water-based mud with polymers that are degradable, so that it doesn't contaminate such table that will have serious significant environmental challenges for people. So once you drill the hole till you pass the water table and get to the next competent shale, which for the Niger Delta ranges from within about a 4,000 to about 6,000. Within that place, once you've gotten a good shale, then you stop, and then you're going to run your casing. Once you run your casing, surface casing is usually the hole size, right, is usually bigger than the casing size, because you need the casing to fit into the hole. So the surface casing is usually about 13.38 in size, while the hole could either be about 16 inch or 17.5 inches. So you carry out cementations. After that, you go ahead and drill the next phase. So the next phase could be intermediate, like written here is optional. Most times you do intermediate in case you want to drill through depleted zones where you have high losses, or you know that the before you get to the target zone you want to go, you have a long hole session and you don't want to tolerate that, or towards the reservoir, you're passing through several reservoirs before the main final reservoirs, and that one is highly pressured. So you need to case off before you enter that zone, because of changing of mud weight that could induce losses. So I would not want to bore you with a lot of that, but let's just take note that intermediate is not always compulsory. You can have it and you cannot have it. After you finish your intermediate, you case and cement, then you drill your production zones. Your production zone, after drilling it, depending on the objective of the well, you will log your production zone. After logging simply means carrying some logging equipment, taking it downhole, and obtaining the parameters, things like the type of fluid that is there. You want to know the pressure of the reservoir fluid, as well as you want to even take a sample of that fluid, so that when you bring it up, you're going to run analysis for fingerprinting of the crude that will come out of there. So after you carry out the logging operations, then you just case the production zone, carry out perforations, and then commence completions. So this, in a summary, is the drilling process to for either oil or gas. So this is just a summary of what I was saying. You first have the conductor casing, right? After the conductor casing, which is usually piled, then you drill the surface casing. You drill the surface hole, sorry. After drilling the surface hole, then you run the surface casing, which is this. After surface casing, in this case, they have an intermediate casing, but this intermediate casing is actually a liner. Why is it called a liner? The difference between a casing and a liner is that if you look at this runs from here to the surface, whereas this runs and terminates here. So liners don't usually it doesn't usually run to the surface, but are terminated on another casing using a liner hanger. So that's what you have here. So these are intermediate liner, and then you have the production casing, and in this case, they also have a production liner. So this is just summary of the discussion we were talking about earlier on. And just look at this. The surface casing is casing of the freshwater zone, which is the default function of the surface casing. It also provides the stand for you to actually put your BOP. The surface casing is where you actually put your blowout preventer. Now, this is just a brief summary of what it looks like, how we use the mud system to help cool the beads, provide hydraulics, and most especially carry cuttings to the surface. So the process starts here. You would have mixed your mud inside the mud pit, use your mud pump socket. It goes through the it goes through the mud circulatory hose to the through the standpipe and then into the Kelly here. From the Kelly, into the swivel, then Kelly, it goes down through the rotary table, through the drill strings, heads to the bits, passes through the bit nozzle. At this point, this is where its work begins. There are cuttings that these bits would have generated, so it pushes these cuttings as it's coming up through the annulus. It pushes the cuttings through the mud return line and goes to the shakers. From the shakers, it goes to settling pits, the gasser, it goes through the filter, the gasser, and then comes back to the mud where the shakers and all the solid controls would have removed the cuttings that were generated while drilling the hole, and then the mud is reused. So it's like a closed system. So now let's dive into the main topic, which is drilling program and why it's important. So this is on my right is just table of content of an actual drilling program. And basically drilling program is basically subdivided into about 5 categories. The first category is the geological program, which contains the well objective. Why are we drilling this well? The location, where is this well located? The general well data, what are the information? What's the rig name? What block is it? The rigs associated and the well schematics. Then we have the well design telling you about the casing, the mud program. I guess there was a question in the icebreaker that you must have your cementing and your mud program. That is under the section known as the well design information. Then we have the formation evaluation. You want to carry out logging, what type of logging are you carrying out for the well? Then we have the operation sequence and then the appendix. So these are just the key subdivisions for a drilling program. So let's look at them individually. We have the geological program. We start with the well objective. So you need to clearly state in the drilling program what are the reservoirs you're targeting. So in a particular well, they have different types of well completion. You can have single completion, single multiple. That means you're using one tubing to tap from several reservoirs, or that's a tango well, or dual string, long string, short string, targeting each of them single reservoirs or targeting multiple. So you need to clearly state in the program what is the reservoir you're targeting. Okay, I'm targeting reservoir E1000, F1000, and then my well will be landing at a particular depth, which is the depth of the last reservoir, let's say 11,000 feet MD, and to be landing in an inclination. So you need to state this objective. You need to state your HSC objective, which is always zero fatality. You also need to state what else are you planning to log. What's the MPT that you can tolerate? Is it less than 10%, less than 5%? So you state all this in the well objective. Next thing is the location and field history. You talk a bit about the field and the location, for instance, and this is just a sample of what a location looks like. So you can be talking about the Alakri field that is located in OML 18, that is just about some kilometers down south of Port Harcourt City. So these are the things that you just want your reader of the program to actually understand, because they will need to know where this well is. Then we have the general well data. So in general well data, these are the informations that are listed in general well data. You first say the block. So which block is this? Just like in this first image, this is OML 18, but in this well data, you can just say, oh, it's in OML 103. What's the well name? So usually you have two names. You have the pre-spod name and the actual well name. The pre-spod name, most times they use the reservoir as a combination to form it. And then once you spot the well, it will now become a name from the last well on that location. So let's say the last well on that location is actually, let's say Alakri 20. So once you spot this well, now the next well will now be called Alakri 21. Next one, Alakri 22. So that's how you name your wells after spot. Then what type of well? Remember I told you we basically have 3 types. So this one is a development well. That means you intend to produce from it. Operator, you state the operator, the plant spot date, the rig type, down to the primary target. What are your primary targets? So in this case, it's E7000, G1000. Where is the plant TD of this well. Where do you want to drill this well to? You also state that, and you also state the type of completion, as well as the total cost and number of days you planned for the well. So you also look at the well target. This reservoirs or primary target talked about. Where are they exactly? You put their coordinates under this well targets, the prognose tops. You list the different stands that we hope to pass. That's if you're drilling through a brownfield where you have this previous information. The well hazards and risks. This is very important. You need to list the risks that are involved, because this is a very expensive venture. You can see, for instance, a well can cost as much as 20 to even up to 40 million US dollars. So you don't want to just go into this without analyzing such risks. What are the risks? One of the primary risks we have is what? A kick that could actually lead to a blowout. So you don't want such. So you look at all the risks that are associated. Are you going to have losses? Will you have, is there potential for differential stickings? There are lots of risks involved, even as little as community interference too can be a risk that will lead to MPT. Down to the well schematics, you also list the well schematic. Well schematic is just like what I earlier showed. If I can go back, this is what is known as a well schematic. So you put the casing, the depth, where to be set, and so on. So the next is the well design information. So in the well design information, you look at the directional planning. If I may ask, if you want to move from PTI to a refinery junction, I guess most of you are in PTI, right, Christabel?
Yes, we are.
Okay, hope I'm not too fast, please.
No.
Okay, so if you want to move from PTI to refinery junction, can someone mention one way that you can go to refinery junction from PTI? Christabel,
You
how
pass
can you go to?
through Palace Junction.
You pass through where?
OVA Palace Junction from out gate.
Okay, so that means you're passing through your main school gate. You get to Japa or before Japa Junction, you branch up through Ovie Palace, right? And you head to refinery, right?
Yes, sir. Yes, sir.
Okay, so what's the second way you can head to refinery junction?
You pass through PTI Junction.
Fantastic. You can pass through the major express, PTI, get to Efuru roundabout, and then you head towards the refinery. Am I right?
Yes, sir. Very correct.
Yes. And then there's a third option. You can pass through your back gate and just bust out at refinery junction. Is that right?
Yes, sir.
Good.
Sir.
Sorry?
Yes, yes, yes.
Good. So you can see that there are various ways you could take to arrive at refinery junction. So if I may ask, out of these three ways we've listed to head to refinery junction, Christabel, if you're the one and you wanted to head to sorry, I'm just calling you Christabel because it's a name that, and she's the person here. So, okay, I'm not saying other people's names. If you want to go to refinery junction, Christabel, where will you pass?
I think I'll take the baggage.
You take the back gate. Exactly.
Yes,
Why do you want to take the back gate?
because it's faster.
Faster, shorter, easier. So in oil and gas, what we want to do is always what? Keep it simple. So you just want to pass through the back gate to save you a lot of cost. If you're passing the back gate, you might just spend only 100 naira to buy water because of the trekking you trek. And you get there before that. Cheap cost than passing through the main express where you spend money for on keke or the other one that's longer. But now, what if we already have we have like a restriction? For instance, that back gate is locked and they say no student can pass. That means you have to start thinking of what alternative way to do what? Head to refinery junction. True or false?
True.
Good. So in this case, for oil and gas, it could be that they've drilled a well that passed through that back gate and headed down to, is that Newcastle Hotel or that refinery road, right? So if there's already something restricting that place, you cannot go ahead to do another one because of what is known as collision risks. So directional planning just is simply I'm at this position, I'm at a particular position, and there's a particular surface location and how to target a particular subsurface location, which is I'm at PTI and how to go to a refinery. So the very first thing my head will tell me, I pass back gate. But if they not say, no, you can't pass back gate because of another well is already there. You don't want collision. You now start thinking, how else can I pass? Should I pass through the express or should I pass through Ovie Palace? Now, if I pass through the express, is if I pass through Ovie Palace, it's complex. I'll be bending and bending. But if I pass through the express, it's a lot easier. So, looking at this chart, this is just simply what a directional plan looks like. So, in this place, we have a target here, we have a target here, and so you move. There are different terminology I'll be using here. So here you can see that you start deviating from the vertical, right? Your deviation from the vertical is called inclination. And the point where you start moving or deviating from the vertical is called your kickoff point, KOP. So once you kick off and you start moving in this direction, you'll be moving at a particular angle. You can now see that here is straight. So here you're building, here's your build point, here's your tangent. You hold tangent till you drop. This is your drop point till you get your target point. So this is just your true vertical section, looking at it in one direction. So you have to make this particular plan, because if you don't make the right plan, for instance, if you're meant to go to a refinery and then at the end you went and placed your what do you call it? You went and planned. Oh, sorry, you plan to go to a refinery and at the end you headed to a front roundabout and stopped. Will you be able to see what you're looking for in a refinery junction?
No, I don't think no.
Exactly. So you need to plan right and have others also review that. And one of the challenges that could arise to such is using the wrong depth reference. So in the well design, you have the directional plan. You also have the mod program summary, where you'll be looking at the different host section. So in this case, this 24-inch is like our conductor. The 17.5 is our surface hole. So you say, what type of, where am I going to have the CD for this surface hole? You can see it's 6,000 MD. MD means measured depth. Then you have what type of mod system should we use? Like I said, for surface hole, we use environmentally friendly water-based mod. So in this case, they are using KCl polymer mod. You're not using any oil, so here is not applicable. What's the density? So this density is to give us hydrostatics. So I wouldn't want to explain this whole thing because only mod engineering on its own is another full topic on its own, because each of these are different services that is being run. Directional planning, you have the directional drilling companies. For mod program, you have the mod engineering company. So they'll give you all this as a guide that will help us to safely get to our objective. Very important parameters you have here. Most especially, you see this density is very important. Very, very important, because it will help us to prevent things like kick. It will help us to prevent things like caving. It will also prevent us having differential sticking. A lot of things revolves around this mod density here. So after that, you also have the casing program, where to tell you the grade of casing, the connection type, the burst, the collapse, that will help us prevent such challenges as burst and collapse, having the casing fail on any of those conditions. We also have the cementing program, the pore pressure, fracture pressure prognosis. Next on the drilling program, we have the formation evaluation program. In the formation evaluation program, we'll be looking at things like the mud logging, like earlier mentioned during your tiebreaker. You need to evaluate the cuttings to see the size, to know if the bit is bit balling, or if you're having cavings. If you're having cavings, the cuttings coming out will be larger. It won't be the bit that will be cutting it, they'll just be breaking. So you'll be examining that. You examine fluorescence once you've gotten to the reservoir zones. Or if you got into the shale you're expecting, because they'll be telling you what is coming out, the amount of sand or shale. So if they tell you, oh, probably you wanted to TD at 6,000, but 6,000, what we are seeing was 80% sand. You can't set case in there, so you go deeper. So probably you reach 6,100. They say, oh, we are seeing 80% shale. You'll be like, oh, fine, let's call TD. this is fine for us to set our casing. So that's the importance of this mod logging. Then survey, and so that means you keep monitoring that. You also have the survey and LWD logging, where for the surface hole, you have different things you want to do. You want to run your gyro in case there are other casings there, because there are other casings, your MWD, LWD will not be functional because of magnetic interference. So you have to run your gyro. So for your 12 1/4 inch hole, these are the various tools you can run. You have your gamma ray, your caliper, resistivity, and others. All this will be defined in the sorry, just a moment. All this will be defined in the formation evaluation program. So the next you have is the operation sequence, right? So let's take, for instance, let's go back to the analogy of how we get to the refinery junction. Where and Christabel made us know that passing the back gate would be the best for her because it's the shortest. So for us to know that is the short, we know it's the shortest. So if we want to go from PTI to refinery junction through the back gate, how long do you think we should plan for us to walk that distance from PTI to refinery junction? How long do you think it would take?
I think to be less than 5 minutes.
Less than 5 minutes. Fantastic. So the
Yes.
very first thing you need to do is, where am I right now? If I'm in my classroom, how long will it take before I'll get to the junction? How long will it take for me to get to the gate? Then how long will it take from the gate to the refinery junction? Am I correct? So that sequence is how it is in oil and gas drilling operations. Also, we have a sequence of activities, right? So we start by the rig move, the rig acceptance, and the rig up. The rig was not in that location. It should be somewhere in the rig contractor's yard or another location. So they need to move to your location. How many days do you plan to do it? For instance, you said it's 5 minutes to take you to a refinery junction. Now imagine you now send whose name will I call now? You sent Isaac to please go and help you get something at Refinery Junction, and you know it's going to take 5 minutes, but in your head you're like, okay, let's make it 7 minutes, just in case he sees his friend or he's Jason. And the next thing, you called Isaac after 1 hour, and he said he has not gotten to Refinery Junction. How will you feel?
And I feel maybe he did not take that particular route.
Okay. You see, you suspect either he didn't take that route, or you might think that he had a challenge on the road. Probably some boy stopped him, or anything at all, but something must have delayed. So, but the very first thing is you need to plan your activity and know, okay, this is the time I'm expected to finish this. And that timing is what you use to plan your budget. So in the sequence of activities, as you can see here, we have this rig acceptance. After that, you spot the well, you drill the surface hole, you cement, then you drill the next hole section, you cement that whole section, then you run what they call it, you cement the line also, you drill the next whole section, the liner, and you cement, and then you do your completions. So this just shows you a summary of the planning. So you can have plan and actual. Actual means once you start the activity, you now start tracking how long it took based compared to what you actually plan. And the whole thing is to ensure that you actually deliver this in less days than what you actually planned. The final aspect of the drilling program is the appendix. It contains other generic informations that are still important. For instance, what type of bit would they be using for the different hole section? What is what are the properties of this bit? Where have it been used? The other locations where it's been used or something. Then you can also look at the casing design. Did it meet the criteria? Do we have any failure in any aspect of the casing design? And then you also look at the anti-collisions. Are there other wells that are close by? Do we have any collision risk? So all this will just be put in the appendix place. The type of BHAs, different informations will all be in the appendix for further knowledge, or they were actually used to build the drilling program itself. So now let's go to the final aspect, which is the drilling operations and monitoring. So now you have finished planning. You have said, okay, it's going to take 5 minutes to get to refinery junction. The first 1 minute is to walk from my is to stand up from my seat. The first thing is for me to stand up from my seat, right? And I take to take about 30 seconds to stand up from my seat. The next is to walk from my seat to the class door, which will be about 1 minute from the class door to the junction. So you break down that. So for drilling, like we mentioned when we started, the very first activity is the piling of the conductor casing. And I've explained earlier what piling is like. It's just like how you hammer your nails. So in this case, you're using a hammer to hit the conductor casing, pushing it down until it gets to the depth of refusal. So while doing this, there are some key parameters you would love to monitor while you're actually hammering that conductor casing, because there's a way, just like the nail. If the nail reaches where it cannot go further, the more you hit the nail, you think it's going down, whereas it's actually buckling or bending. So it's decreasing, but you don't know that it's not doing what you want. So you don't want that. So parameters you monitor during piling operations includes: one, the blow per foot. The blow per foot is just talking about the way you hit the hammer. Boom, boom, boom. So you want to know, because the conductor casing, they would have tallied it on the conductor casing, which is about roughly 38 to about 42 feet, right? 38 to about 42 feet. That's like range 3 conductor casing. So if, let's take for instance, if it's 40 feet, that's the conductor casing, someone would have tallied 1 feet on each of the, would have just measured 1 feet, draw a mark, 1 feet on the conductor casing, so that when you start hammering, right, you'll be hammering, 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 hammering. You know, you count the number of times you hammered. That's the blow. The blow is the hammer. The number of times you hammered that conductor casing until it went down by 1 foot, right? And this number of blows is depending on the energy, the hammer energy. So they can set the energy depending on the type of hammer they are using. So if you're using an S90, it can go as large as 50. So once you set the energy, you don't start with big energy. You just start with little energy. You can see from this chart, they started with, first of all, it had free fall, then they started with about 10 kilonewton meter. So once you hammer with 10 kilonewton meter, you just be counting 1, 2, 3, 4, 5, 6. You count how many times you hit the hammer till you achieved 1 foot. That is what they mean by blow per foot. So if you keep hammering, 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 you get to a place and you see that you're not moving as fast as before. You can now increase the hammer energy. And each of these conductor, depending on the grade, has the specification, the manufacturer's specification. So in this case, for this job that was being done, the manufacturer's specification is that if you're using a hammer, if you're using an energy of about 45 kilonewton, right, that you should not exceed about 116. So what you need to know is just like that, our nail. Most times you see that when the nail was refusing to enter, what do? You increase your strength, right? To hit it, to force it. But what they're telling you is, this is our specification. If you force it more, you spoil that casing. So in this tracking, what you do daily is when they send you the blows per foot and the hammer energy, you're tracking this blow per foot to ensure that it doesn't pass this level. This particular level you're seeing here doesn't pass it. And this hammer energy, you expect it not to also pass this level. As you can see, they only passed here by little. They moved from 45 to 50 just to check that that was truly the refusal point. They only did that for about 3 feet. So that's basically what you'll be tracking, because if you use 50 or 60 kilonewton, you just end up buckling the conductor and you ruin that particular slot. Another thing you track is the MPT. MPT simply means non-productive time. Now let's look at this chart. Please, sorry, am I too fast? Are you guys following?
Yes, we are.
Okay, I don't want to hear Crystal Bell's voice now. Please, who else? Are you guys following? Can someone else just let me confirm for me you can hear me and you're following?
We
We
are
can
following,
hear you,
sir.
sir, and we are following.
Oh, Tina,
Yeah,
I
we
can
can
hear
hear
your
you.
voice.
Yeah, we are all following.
Okay,
Yeah,
and
same here.
I hope it's not boring.
No,
No,
it's
no,
not
no, no,
boring.
no.
It's very interesting.
Okay, thank you.
Oh, yeah, my boy.
All right. Aidan, I can hear you. Sorry, Tina. So, like I said, the other thing you monitor is the MPT, that's non-productive time. In this chart right now, so like we gave an instance, Christabel sent Isaac to go to refinery, and she planned that Isaac is going to reach the refinery in 7 minutes, right? But Isaac now reached the refinery in 10 minutes. And we know that you can reach that refinery in 6 minutes, but he reached in 10 minutes. That means something would have what occurred. That stuff that occurred that interrupted our perfect plan of what we are meant to achieve is the non-productive time. Is the time that was not planned for. For instance, Isaac is going and he now went and started discussing his friends. Definitely, Christabel did not plan for that because that was not what she instructed him to go and discuss. So in this case now, in this piling operation, the piling operation was planned for 7 days, but you can see that in actual sense, they actually spent what 10 days, more days than was planned, which the more days now will result in what more cost. So what are the issues that facilitated this? You see that what crane got stuck in traffic while it was coming. So the whole rig down process took a longer time. Pattern of crane hose, they had to fix hose, use one full day to fix a hose. They had electrical issue with the piling hammer that was leaking. So all these minor hours will now make us to spend more time than what we actually plan to do. But it's good for you to actually track these MPTs and these so that you can actually recommend solutions for this so that when you're carrying out the next piling operation, all the solutions recommended will help to reduce your MPT. The next we have is the drilling operation itself. So during the drilling operations, there are a lot of things you track. And like I mentioned during the mod program, that mod program that was displayed during the planning, because you plan from your planning, once you've planned during operations, you now have to diligently follow that plan that was made. Just like what Christabel said, if Isaac did not get to refinery in 5 minutes, what happened? He must have done something else. Maybe he followed another place. So you told him to use a mod weight of 10 ppg. He went and started using mod weight of 15 ppg. That's a huge problem. Or you've told him to follow this path from PTI. This is PTI. He should follow through the back gate and follow his classroom back gate and then walk down to Refinery Junction. But Isaac himself went like this, went like this, went like this, and so he followed a different path from what was instructed. So you need to monitor all those things that were listed during the drilling program. For instance, the mud parameters, you need to track the weight. If you've been to a drilling location, you will always hear one particular mud property that they always scream on location: mud weight in and mud weight out. They'll always scream. Let me take, for instance, you hear mod weight in 10 ppg, mod weight out 10 ppg. Then sometimes you can hear mod weight in 10 ppg, mod weight out 9 ppg. So can someone just tell me what could have happened that will make the mod weight to decrease in its weight from 10 ppg to about 9 ppg? If you know, just go ahead. Hendrix, you can go ahead.
What I think can cause the information to
Okay, so your network
so when it's
cracking. I don't know if it's just me. Can you come again, or can someone else just mention what could have resulted in our mod losing its weight? Hello?
Okay, sir.
Okay, Christabel, go ahead.
And for the moderates to have increased, I think probably the volume of water that was used was probably too much. was more than the volume that was supposed to be used.
Okay, but this one you already mixed it with the mud and it has entered the hole, and it entered the hole as 10 ppg, but when it was coming out, it reduced, the weight now reduced to 9 ppg. So let's just think, what could have caused this?
Um, Good evening, sir.
Yes, good
Can you
evening,
hear me?
sir. Yes, sir.
Okay, this is another one that can affect mud weight in the sense that maybe your formation fluid mixed with your mud in whole, and this can reduce the mud weight. When it's coming out, you can observe that the mud weight has reduced because of the mixture of formation fluid, which indicates a peak influx.
Fantastic. Fantastic. So it's just like, let me see now. Good. We have our liquid wash, dishwashers that we use to wash our plates, right? Now imagine most of us, we know the popular brand like Mama Lemon, or someone has mentioned on that popular dishwash brand.
Morning fresh.
Morning fresh.
Fantastic, Morning Fresh. And we all know what it looks like, right? Now imagine you now poured Morning Fresh to wash your plate. And the next you say, saying, pa, 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 pa. It was not coming viscous. It was the first thing that will come to your mind.
I think maybe it has been diluted or something.
Beautiful. You've just said it. So that is the key term. That means there is what? Contamination. But in this case, Morning Fresh is what? Dilution. They must have added water, right? So that is how it is. So if there is a drop in weight of the mud, it is a big problem, right? It is a big problem. It could have been diluted, like you mentioned. So you must have maybe had influx. Probably you had gas, which is lighter. If you mix heavy something and light something, that heavy something will lose its weight. You could have gas, oil, or even water in the formation diluting our mud. And once they mix, they'll drop a lot of properties. And one of the dangerous properties that they drop is our mud weight, which if they drop the mud weight, we have the potential possibility for a kick, which can lead to a blowout. They can also affect other numerous properties of the mud, but the primary thing we usually check is that mud weight in, mud weight out, because we want to always make sure that we are maintaining over balance. Other things could also cause it: equipment failure. Probably the mud, what they are using to check the mud weight, which is the mud balance, probably they did not calibrate it properly, and then it had issues. I've seen that happen before with hydrometer. The two different hydrometers were giving two different readings. So who will you bring? The mud engineer? No. You have someone that was filtering using another hydrometer. The mud engineer had his own hydrometer. So that was like an equipment failure in such a case. So they just had to use one so that they will both have the same reading. So very key, very important. You monitor the mud parameters. Apart from the weight, if you're drilling through your surface hole, which one of the challenges is clay? You also look at the chloride content, the KCl, content of the water-based mud, because you don't want, you know what clay is? Clay or shale, if you pour water on clay, what happens to clay when you pour water? It begins to swell, and that swelling will reduce the diameter of your hole. So you have a bit and everything passed down. Water makes the upper end to swell. If you want to bring out that bit, you will get stuck. There is no way, because the part that is bigger is down, the hole has reduced. So pulling out becomes a very serious problem that can lead to stuck pipe. So, but if you keep monitoring that property, let's say you had a dilution or anything, you now say, my case here, the mod program said, it must be between range 12 to 15. I'm seeing some dilution. Either at the reflow, somebody is pouring water or someone is pouring water in my pit. It has reduced to about 10. If you keep it for that long, it will cause problems. So you need to go and put some chemicals to optimize it. So you have the superintendent, you have different people that monitors all this. So you monitor it to ensure that it is up to the spec that was stated in the program to prevent challenges. Because once any challenge occurs, what you'll be having is what? Increased cost. MPTs, which is not what you want. You also have the up and down weight, rotating weight. So you have the weight of the drill string when it's going down. You have the weight when you pull, when you're tripping. You also have the rotating weight. You're establishing this to know so that by the time, let's take for instance, the pulling weight is about 200 pounds. That's what you're using to pull all the BHA. And then the next thing, when you try to pull to see what it is, you're not seeing about 300 pounds. Something that you're using 200 pounds to pull, you're not seeing 300 pounds to pull the same thing. Who should I ask now? Can someone tell me from their thought what would have happened? Hello? Please confirm I'm still audible.
Yes, sir. Please come again with the question.
Okay. Let's take for instance now, you dug a hole, right? Are you with me?
Yeah.
You dug a
Yeah.
hole and then you carried a stick or a rod and put inside the hole, right? And then the force with which you use in pulling it up, you only use about 200 pounds to pull out that rod. The next thing, you dug the hole further, you put the rod again. You're expecting that, or not even you dug a hole further, that same hole, you put that same rod again, and then you wanted to pull it, and you're seeing that normally it's meant to be 200 pounds, you're meant to pull it. But now you've pulled up to 250. You're using 250 to pull it and not 200. What do you think would have happened to that hole that is making you use more energy to pull? Hello?
Huh?
Yes, sir. Can you hear?
Okay, I think Faith was about to talk. I saw Faith is talking. Faith, go ahead.
It either may be pipe sticking or key sitting. Like maybe
Fantastic. Fantastic. That means what is just telling you that a problem is what? Developing, right? That there is a form of what? The language is what? A form of restriction. You're having key sitting, you're having different, what do you call it, mechanical sitting. But what you just know is that there is a form of what? Restriction. That means something is holding down your rod that will need you to apply more force to pull it out. So by the time you've seen those indications, because before anything happens, there will be signs. So by the time you just start seeing those little indications, what do you need to do? Just pump and circulate to remove that restriction. That is why it's always important to monitor all these key parameters. Another key parameter is the ECD, equivalent circulating density. What it helps you to do is for you to know how clean your annulus is. By rule of thumb, your ECD should be plus or minus 0.3 away from the mud weight. Immediately you're seeing your ECD going higher than 0.3, please circulate that well. If not, you're having cuttings. Your mud is not properly cleaning that hole. You're having cuttings piling up, and cuttings piling up means that once you want to start pulling back your BHA, you now start having that restriction. If you're lucky, you can use your jar to free yourself. If you're not lucky, bam, you're stuck. So the next thing we have is MPT. MPT, like I mentioned before, non-productive time. So you did not monitor the mud properties well. You got stuck. The period you took to free yourself is MPT. You were meant to carry out, run your casing, and you already know the speed you're using. It's meant to take you 2 days to run your casing. You use 3 days. Why? The tubular running equipment failed. They had to fix it. The, what do you call it, diesel filling to location, or community stopped the work. All those things, did you plan for that? No. Those are what? MPT that delayed the project. So you need to track it so that next time you want to go out and drill, you'll be better prepared so that once those things occur, for instance, the tubular running equipment fails, if it failed before and they had to fix it and it took them like 12 hours, what's the solution you can do? Rather than having one tubular running equipment, they can bring two. So if one fails, they just drop one and bring the other one. Rather than having 12 hours, they'll just use 2 hours to rig down and rig up. You save time. So that's why MPT is good. You track MPT so that when you're planning the next well, you can use the lessons learned there to plan for the next one. Survey, just like what I mentioned in the analogy to refinery, you want to move from here to here. You want to move from PTI to a refinery, and then someone moved, person was moving, then the person deviated, and the person went to a phone roundabout. Will the person still see that reservoir a person is looking for in refinery junction? No, because you've deviated. So you need to track the survey, which is being sent by the MWD, LWD people. So once they are sending you these parameters, you plot it and track against the planned trajectory. They have what is known as catch-up. Probably they are moving like this. They plot. Omo, we are deviating, they'll come back and do a catch-up to be here. Or they are here, they've gone like, they'll be like, almost see where the reservoir is. So if we continue like this, we'll miss. Let's just change our path and come back this way so that we can still hit the reservoir, because the primary objective is to hit those two reservoirs since it's a development well. We also have bit parameters. You monitor bit parameters to know when to pull out the bit, and you track your cost, your rig spread, your daily spread, and your cost, so that you know when you're getting close to cost overrun. If you have more MPT, because during your AFE, they plan for MPT about 5 to 10%. But if you start going higher than that, definitely you'll be breaking this cost. Other things that you can actually monitor during casing and cementing operation is actually casing tally. Casing tally simply means you want to run casings. So let's take, for instance, you want to run casing to about 6,000 feet, right? And each casing, let's say 6,050 feet, and each casing is about 1,000, sorry, let's say 100. Each casing is about 100 feet. Can someone tell me how many casings you need to run to get to 6,000 feet? Did you get my question? Hello?
Please come again,
Yes,
sir.
sir,
We
we
did
got
not
your
hear your
question.
question. Okay, I
Okay,
did not hear.
so I said you want to run casing. You've drilled your surface hole to 6,000 feet, right? And each of these casing is 100 feet. Now you want to run these casings to 6,000 feet. How many casings would you need to run to that 6,000 feet? If each
60.
casing's length, is about 100 feet, how many?
60.
Beautiful. So when you request for casing to come to location, you will not just request for 60, you will request for probably 80. Reason being that while they are making up the casing, they might see, because they deliver the casing from location to site, they are using forklift crane, they can bang each other, some of them thread will spoil, and so on. When they do NDT, some of them will fail. So you might have some that way. And then from location where they are, they must have been stored for a long time. So most of them will fail. You'll find out that out of the 80 that they brought to site, probably only 70 will be usable, right? And when you're using them too, when they are tightening them together, when they are making a connection, they can have challenges too. Why doing that? So now you've likely stated that we need to run what, 60. So what you do, casing tally is simply measuring each of these casings length, because you know that you're meant to use 60 casings, but these length are not all 100 throughout. Some of them will be 60, some of them will be 80, some of them will be 90, most of them will be 100. So you have to know their length, the length of each one, and then you have to label them 1, 2, 3, 4, 5 till the 75 that you've tallied. So imagine you're now running the casing. You're running. And then the next thing, you're just at 50. And then they now tell you, we are done. No. You said no now. The tally says it's meant to be up to 60 that I need. So that's the essence of casing tallying. You need to be counting and be making sure to know that, oh, okay, I know that they've run this. By the time they start reaching around, let's say 58, they might actually get there because of the varying length of the casing, and you must have computed that. That's why you track that. Then you have what is called top and bottom plug. Very important during casing. I don't know if this video will be played, but this here is a cement head. So how the top and bottom plug works is this thing can actually mess you up. but thanks to the MPT that they've learned from other places, they've engineered so many ways to ensure that it doesn't mess you up. For instance, previously they are usually the same color, but now they separate their color for ease of identification so that you not mistakenly put the wrong one. Because if you put your top plug first before your bottom plug, anything you pump would not go anywhere. You just cement your entire casing and not the annulus you want to cement. So you first load, what they call it, close this pin here. It will close. Then you load your bottom plug here. By the time you load your bottom plug, then you close here, and then you load your top plug. While doing this, the DSV, everybody will snap and do that to be sure that you put the right one. So the cementing process starts by first pumping the mud. You carry out circulation to make sure that you agitate the hole, and then you put a spacer. By the time you've pumped the spacer, right, then you now release this pin, move it in the other direction so that this bottom plug will go down. Once it goes down, you now open here, close here, you close this place, you now start pumping your cement here. The cement here will now push this bottom plug down. As it's pushing it down, as you've pushed and you've pumped the volume that you need, the next thing is you close here, you open here for the top plug, then you use your spacer and mud to push the top plug, and then they'll bump each other and you have a good cementing job. You also monitor the cement properties, things like especially the weight of the cement. You also try to know the thickening time. You know the accelerator or retarder that is added to the cement to know when, so that you don't have a flash set inside there. So you need to know the temperature of the formation also. So basically, once you monitor all this and you do things according to the plan that was designed in the program, because that program is usually sourced from different teams and from different experiences gathered by other wells that must have been drilled around the field. So with that, it's always good to just strictly try and go according to the drilling plan. Where you start having challenges most times is when one person fails to do the person's work. Probably did not you're meant to do 10 ppg. You were like, you just gonna announce 10 ppg in, 10 ppg out, whereas something is happening, you didn't measure it, you were just there now because you got tired, you were pressing your phone or being distracted. That's what causes issue. So, but if you actually monitor this operation and you go as per what the program is, you actually drill the well successfully to your TD and make everyone happy, because you'll be able to assess the proposed hydrocarbon that you drill to. So thank you very much, everyone. I think this is time for question and answer. So I'm open to that. Thank you. Over to you, Christabel.
Okay, thank you very much, Engineer Alize Ogochukwu. Even though you don't want to hear my name, my voice again, I'll still talk. Oh. I almost finished my name during the lecture. Okay, thank you very much, sir, for this amazing lecture. For me, I learned a lot. I don't know for other persons. So please, the communication has been done and it requires feedback and responses. So if you know you actually gain something, just drop your comments and also your reaction. Before we take on the Q&A session, we'll do a little bit of photography, which will be taken by Miss Tina. Miss Tina, please, over to you before the Q&A session.
Okay, good evening, everyone. If you are in this meeting, it's time for our photograph session, and please let us kindly our camera, please. Let's show our faces. Please, if you can see me, you can actually turn on your camera.
Christabel, your camera is not on.
I'm not in the position to turn on my camera. I'm sorry.
No issues. I was just teasing you.
Okay, we are done with the photograph session. Thank you, everybody.
Okay, thank you, Miss Dina, for the photograph session. So we'll be taking our Q&A session now. Please, if you have any question, you can just raise your hand or drop it at the chat box. So Mr. Ogochukwu can take your question. Okay, we have Enoch. Enoch, please go on with your question.
Okay, good evening, sir. Good evening, everyone. First off, I want to say a very big thank you to Mr. Ogochukwu for this insightful topic. So my question is, when you actually you want to drill a well, you want to deviate, that is if you want to, how do you deviate? Because it's steel pipe. This question has actually like, it's always in my mind. How do you want to deviate your well? It's steel pipe. Because you know when you're drilling a straight it's just a straight well. That's very easy. That's like it's easy to know that you're drilling a straight well. But when the well is actually inclining, I don't know how it's being done. If you're using a bending pipe or no, but I don't think they're using a bending pipe. So that's just my question. I just need an insight on that. Thank you very much.
Okay, so do I respond immediately, Christabel?
Yes, sir, you can.
Okay, so you go to Christabel's pastor and pray for the pipes. That very easy. We always call Christabel whenever I want to bend the pipes. So that's it. Augustina can actually attest to that. That's what we do. Very easy, very easy. If you're not a Christian, you can go to the mosque or anything. So next question, please. So I'm just kidding, by the way. So I'll tell you something to do right now, right? Okay, you might not be okay. You can actually do it. You can actually do it. So your questions comes in two parts, right? The first part we would have to deal anyway. Let me make it easy. I will not want to complicate issues. So if you add 20, I'll just tell you to try it, right? Carry straws. You who asked the question? Enoch, right?
Enoch, yes.
Yes, sir.
Enoch.
Okay, Enoch, you know a straw. Do you know a straw that you use in drinking your
Yes,
Coke?
sir.
Good.
Yes, sir.
Just go and buy a packet of straw, right? You know a straw is one full item. If you bend a straw, one straw, what do you think will happen to the straw? Enoch.
Well, I can hear you, sir. If it's a single straw, the one we know, it will actually bend, but like it will bend all the way.
It
So
will
it might
deform.
actually,
It will
yeah,
deform.
deform,
It
yes,
won't.
yes.
It won't bend. Okay. You bend it to some extent, but the next thing to do what? It will deform. True or false? Hello.
True, sir. True,
So
sir.
that is how it is. A single pipe on its own cannot bend, or it can bend to its elastic limit. This is physics now, where if you stretch it beyond the elastic limit, it fails. That's why during casing design, we have what they call triaxial load. So if you do that, it's going to fail. But if you have several straws, you can go and try it out, Enoch. Carry 20 straws together. Those 20 straws, you can bend all of them to even form a circle. Go and try it out. Are you with me? So
Yes, sir.
the more straws you put, it now has this spaghetti form that it can bend. You can go and look for a hose. These long hose they use to fetch water. Get a very long hose, form a circle with the hose or bend the hose in different directions. Now carry your straw of 20. You see that you're pushing that straw will mimic that hose. But if you put one straw, that one straw cannot form a circle. But by the time you put so many, it has this behavior to behave. You just see that if you can bend it completely to pass through. So that's how it is in drilling. Because of the length that we have, that's why when you're doing a trajectory, you not just see that they start the deviation from 60 feet or they start the deviation from 300 feet. Usually, they start deviation from at least around 1,500, and 1,500 for around let's say 50 pipes, you'll be talking about over 300 pipes. So you've had that elastic behavior or bending behavior come in place, like the scenario for the straw. So I don't know if I've answered your question. You can actually experiment it.
Thank you, sir. Thank you, sir.
Then the other part I said is a bit complex is if you're talking about the tools. So they have different things. They have directional tools. You have your mod motor, which is cheaper, which most companies use. And then if you want to use go faster, you have your RSS. The mod motor has a 1.5-degree bend. So that's why I said you want to go all into technical, but all that is just telling you how it helps to achieve the deviation itself for the casing, which is what your reference point was. We'll now try to follow based on the long depth and several casings being added to have that spaghetti effect. Thank you very much. Otherwise, please go to Christabel's pastor. Thank you.
Okay, we have another question in the chat box. So I'll read it out. They said, while running the 958 casing, how do you use your float shoe and float collar? That's the question.
The person asking the question, may I ask, who asked the question?
It's promised. No, sorry, Faith.
Faith. So please, if I may ask, Faith, what is float shoe? What is float collar? Myself, I want to learn. Faith, can you unmute and tell us, please? So that before I start explaining, we have an idea of what we are talking about. Faith, go ahead.
That's why I'm asking you. You mentioned casing. So going to do research, I saw float shoe and float collar. How is it applied and what's it used for? That's the question I'm asking.
Oh, okay, because you only mentioned how is it applied. You did not ask how is it, what is it used for. Okay, so you saw float shoe and float collar. Fantastic. So you want to run casing downwards, right? While you're running this casing, right? You would not want you're running it as what do you call it, close-ended. You do not want any influx. For instance, okay, let me say you start running this casing and you have a kick. Faith, you understand what a kick means?
Yeah.
What's a kick?
It happens when the formation fluid overpowers the hydrostatic pressure.
Of the drilling fluid. Fantastic. Now you're running in casing, right? Let's take it. The casing, it's open-ended. Both sides are open, right? It's a steel
Yeah.
pipe. Yes, both sides are open. You're running this casing now. If the formation fluid enters into the formation, it will counter the hydrostatics of the drilling fluid, and then to be entering the casing from both directions, from both the annulus and both inside of the casing. True or false? You know what is annulus,
True.
right? Sorry, let me don't speak big
Yeah.
grammar. You know what's annulus. Good. So that means you'll be battling two challenges, and you do not have any drill string inside to start pumping from inside to solve that problem, and you do not have any equipment to go and mount on inside to cover the internal diameter of that what they call it, casing. So what do you need to do? You need to put a shoe. What that casing shoe does now is it has a float valve that allows only one directional flow.
Okay.
What that simply means that you can only pump something inside, but something from outside cannot enter inside. So if you have a kick, you only have something coming through the annulus with your BOP there that can help you secure the well, but you don't have anything passing through inside of the casing.
Okay.
Are you there? Then for the float collar, Float collar is usually where your plugs land on top. That's where your plugs will land on top, and then you now have the remaining cement inside your shoe track. Your bottom plug will go land there, and then your top plug will go and bump on top that float collar. Yes, thank you.
All right.
And so we have other questions as well. We'll just be taking two due to time factor. So the first question here says, when a driller experiences pipe sticking while drilling and force is applied to pull it out, will the force applied not lead to the caving in or collapsing of the well bore?
Okay, so who is asking the question?
Kemi. Sorry for the pronunciation.
Okay, I didn't get the name.
Ayade.
Ayade. Ayade.
Yes.
Please, Ayade, I want to ask you a question. You put, let me see, where can I mention? What's a good analogy now? Let's say your hand got stuck inside something, right? You put your finger inside something and then it got stuck. What is going to be your first reaction, Ayade?
My first reaction would be to pull it out.
Beautiful. So now, if you use force to try and pull it out, right? And you successfully pull it out, will your hand damage will that your finger that got stuck damage the stuff that was there?
No, sir.
Good. So most times you start by asking when you say no, sir, that's technically right and wrong. First of all, you need to ask yourself, what is there that was holding your hand, right? So that if you use a force greater than what was holding there, right? And then you can use a minor force, you free your hand. But if you use very hard, because you use minor force several times and use a very high force, it can actually damage that and create another problem. That is why you need to first know, why is your hand stuck. If your hand is stuck and you use small force, it did not work, you can easily go and call someone, please get lubricant and pour. Let me see if I can just rotate my hand and free it faster. True or false, Ayade?
True, sir.
Yes. So most times you need to understand why the pipe was stuck. Were you differentially stuck? Because you're actually right. You can be differentially stuck, and based on the force or the actions you're taking, you can move from differentially stuck to mechanically stuck. For instance, let me give you a clear example. You're differentially stuck. Differential sticking, one of the issues is high overbalance, right? High overbalance, presence of thick mud cake, etc., etc. So you were differentially stuck by, let's say, high overbalance. And then the next thing, high overbalance means the hydrostatic of the mud is way higher than the formation pressure. So you now reduce the hydrostatic of the mud. By reducing it to a particular point, you now start having a collapse effect on the formation that was there. And they will start collapsing and you change to being mechanically stuck. Or you're firing your jar to pull, because it's your jar, your drilling jar that is there that will help you when you're stuck. You're firing your jar to pull, and mistakenly you pull so fast, you have suction effect and you can create a kick for yourself. So you need to know what issue it is, and while doing that, you apply it with wisdom. You apply it to a particular limit. I don't know if you're getting. So I don't know if I answered your question. Please confirm you can hear me, everyone.
Can hear you, sir.
We can hear you,
Okay.
sir. We can hear
Yes, we
you.
can hear you.
All right. So you heard my explanation, right? Ayade, please
Yes, sir.
confirm I answered you, or if I did not, you can repeat your question. Probably I skipped what you wanted to hear.
You might not pursue any.
So I think he's having a network glitch. So we just have one more question to take. Adebayo, you can unmute your mic for your question.
Okay. Good evening, Mr. Ogoshuku. Thank you for this session. So, my question goes for mod density. So, your mod in and mod out. Like now, you are telling me that if mod wants to go inside, like having 10 ppg, why the mod coming outside is coming out like 9.5 ppg, that there can be contaminants that really affect it to make the ppg to get reduced, the density to reduce. So, like now, as the contaminant, while drilling, we have freshwater zone and we have brine water zone, which is the salt water zone in the wellbore. So now, out of the question, while drilling to the brine water zone, it can be offshore, onshore, land or location. How can we solve the brine water contamination while using our mud? And now you can be saying that now we will use our oil-based mud. So I have to tell you that while using the oil-based mud too, the salt, the brine water can even reduce the oil-based mud. You understand me? Like now, doing an experiment, like you have your oil. Sorry for using this analysis. So like eating yam and oil, groundnut oil. Why putting your salt? Why putting your salt inside the groundnut oil? It will change the property, it will change the quality. So what other like other solution can we do to correct this this reduction in ppg or the density of the mud? That is the first question. And the second question is about the casing. Okay, I'm talking about the casing that like we want to use 50 stand of casing for 6,000 feet. Okay, now 6,000 feet. He said we will order 80,000. Out of that 80,000, he said we will use some will use 70,000. Some can be bad. So the others that are bad, who will actually pay for it? Like who will account for the payment? I don't. That's what my question goes through. That's the only two questions. Thank you very much, sir.
All right, thank you very much, Adebayo. I'll start with your second question, although I got lost at some point in the first question. Very easy, now just carry the bill and go and give Christabel. Christabel and Tina, they'll pay for it. Yes, so Christabel, Tina, they have money. They'll pay for it. That's it. You've solved it. End of story. What's the next question? So usually, it boils down to some certain things like the drilling, oil and gas drilling. Like I earlier mentioned, there are various services. So actually, those casings are called OCTG, oil country tubular goods. So first off, if you're sourcing it locally, right, off the shelf locally, you're buying it. For instance, what we are doing currently, we are buying it from a particular vendor that probably the rig site is in Delta State, the vendor is in Delta State or Port Harcourt. Before those equipments are carried out from the vendor's yard, you would have carried people to go and inspect it, right? So that it's just like you go to market now. Let me see what you go to market to go and buy what can be easily identified now from outside. Good. You go to market to go and buy pineapple, right? Adebayo, if you go and buy pineapple from,
Yes,
or
I can
let's
hear
say,
you.
yes, you go and buy pineapple, in market, and you bought over 200 pineapples in the market, right? When you're buying this pineapple, what are you going to do? You're going to be examining the body of the pineapple, right? That person selling the pineapple could have over 400, but out of the 400, you find out that you might select one and it's not good. At that point, what do? You drop it back for the person and collect the only 200 good ones. True or false?
True, sir. True, sir.
Good. Now, when you select those 200 good ones that you've bought or you've checked, they are all ripe, but they are not overripe. They are ripe and juicy, that they are ready for you to take. Now, you carried the 200 pineapples to your house. As you're carrying it to your house now, and one of the pineapple falls on the ground, smashes on the ground and scatter, who is going to pay for that pineapple that you've carried to your house? And it fell.
Okay. Me.
Fantastic. You've answered the question. So it does not concern that person anymore. At that yard, you've selected the good ones. You've done the examination. But during handling, that's what is called pipe handling. When they are carrying it from that place to your own location, right? The people carrying it, they use forklift, they use crane. Those pipe can fall off through the forklift, or the forklift can pierce. You know what forklift is? It has those jaws. It can pierce. There are a lot of things that could defect it. That is one. Another analogy, you bought the 200 pineapples, you carried them and kept in your house. You don't have a place inside the room because the smell might not be comfortable. You dropped it outside. Rain fell. You left the pineapple for over 5 months. What will happen to the pineapple?
It was spoiled.
Some of them will spoil. If you're lucky, some of
Yes.
them will still be good. But you have 200, or let's say you left it for over 2 weeks. You still have some that are good. Will you say you want to throw all your pineapples away? What will you do? You need to
You
check
use
which
one
one
that.
that is good
Yeah.
and which one that is bad. Exactly. So, but if someone tells you, if you now you used to do pineapple fruit, you can just carry the 200 and go to your shop, and then you now start making your juice. The ones that are bad, you drop one side. The ones that are good, you use to make your juice. That is the same way you carry from your own warehouse to the field location. When you get to the field location, you now start identifying, I've stored this pipe for so long. Let me see the ones that are still usable, that are still good. The ones that are bad, they are your losses. You can keep them for other uses. They can be used for racking of pipe. If it's a minor issue, if it's a threading issue, they can cut them and make them pop joints and retread them. I don't know if that answers your question.
Yes, sir. Very much. Thank you for the
Okay.
second question.
So the first question, it was very long and I got lost, but if I don't answer it, you can draw back my attention. You're mentioning two things. I hear you mentioning offshore. When you say offshore, are you talking about the sea itself that you're passing through before you get to the formation? Or you're saying inside the formation, the saline water and other things? Which one are you mentioning? Now let me know how to answer it.
I'm mentioning for the both of them. Onshore too, when drilling down, you can actually meet a brine water zone. And offshore too, that one's very, very paramount. You will surely see saline water there. So I'm talking about the two of them. So how can we correct the brine water from reducing our density of our mud? But now you have to answer me that you can use oil-based mud, but that thing too can even decrease the oil-based mud. So what
Okay, so
can we?
let me ask you. Let me ask you, Adebayo. Adebayo, what's your weight?
My weight,
Yes.
uh, just
Okay. Okay, don't worry.
45.
Don't answer me. 45. Okay, don't answer me. So let me take it for instance now. Adebayo, there is a door in your room, right?
Yes, sir.
Right? And
Yes,
then
sir. Yes, sir.
you want to pass through the door. Do you know Tina? Is Tina your classmate?
Yes, I know very well.
Good. If Tina is at the other side of the door and you want to pass
Mm.
through the door and she's pushing you that she wants to enter inside the room, who will overpower each other?
I.
Good. Shebi, you can still push the door and pass.
Yes.
Fantastic. Now, do you know Lokozuma? Those fat Japanese wrestlers.
Yes, I know them.
If that person is at the other side of the door and then you want to push and pass the door, will you be able to pass the door?
No, I won't.
That is exactly what happened. Hey, Jesus, my ear. Who is speaking? Okay, so that is exactly what happens while drilling. So take the drilling fluid that you're using to drill to be thinner. If you use thinner, you've been in your house, you've been agitating, you want to come out from your door. You're the formation fluid, you're the brine or the water, right? If you use
Yes, sir.
thinner now is just patrolling, she's just passing. She now hits your door. She now opens your door. If she opens your door, the very first thing you want to do is to push and come out, right? If it's
Yes, sir.
thinner,
Yes, sir.
you overshadow
Yes, sir.
her and you push and enter thinner, and then you contaminate thinner, which is the mud
Yes,
there,
sir.
oil based or anything. But if it's
Yes,
the
sir.
Lokozuma, The guy will enter your room, lock your door, pass around your room. You will not still pass through that door. True or false? So as far as the weight or the pressure exerted by that mud is greater than the formation pressure, okay, nothing is coming in because it's already holding it intact from having that contamination from entering. But at the moment where that's why you have that planning. You must have done some geomechanics and everything to know what you're going through. You get my point? Yes.
Yes, sir.
But you can also have a situation where the mud weight will increase. Why will this mud weight increase? You're drilling, right? You're generating, probably you're drilling, let's take it through any particular formation, a barite formation, anything. Those cuttings that you're drilling now, your mud is carrying
Yes.
them where? To the surface,
It's carried,
right?
yes, the surface, yes, through the
And they are
annulus.
meant through the annulus, and they are meant to pass through the solid controls, that's the shakers. But these shakers
Yes.
have turned. Rather than them removing those solids from inside, the solids remain inside the mud and it goes to your mud pit. What do you think would happen? Your mud weight will start increasing.
Yes,
So
sir.
that one now is you not carrying out efficient solid control.
Planning.
That's why
Okay.
yes, that's during monitoring. So if you start seeing such, there are two solutions. They'll go and change the shaker screens, and sometimes they'll run what is known as what? A centrifuge. A centrifuge into the pit to actually cut down on that. So I don't know if I have answered your questions.
Yeah, very much. Thank you very much, sir. Thank you. I'm grateful. Thank you very much.
Okay, thank you very much, sir, for this question and answer session. So sorry, everyone, if you have questions that we were not able to take, we're so sorry because of time, because some persons are leaving us actually. So, Adebayo, please, you cannot be waiting 45. Sorry, you cannot be waiting 45. That aside, um, Engineer Ugoshuku, thank you very much once again. And please, some persons are looking for refreshment. You can reach out to Engineer Ugoshuku. He will take care of it. Just reached out to me now.
No problem.
So
Even
we'll be
so this is payback now, Abby. No problem.
Uh,
Well done.
so so we'll be rounding up shortly. We'll be taking the next session, which is announcement by Mr. Ajibola. So please, Mr. Ajibola, unmute your mic, please. I'm not sure he's with us, maybe due to network. So without wasting much time, so there's one question here. Oh. Since it's from your friend, I'm not supposed to read it, but since it's from your friend, I'm going to read it. It said,
Who is my
yeah,
enemy?
it said while calculating workers' space, NPT taken into consideration. So please give him your answer.
I didn't get that. Come again in the question. I didn't get that.
It said why calculating workers' pay is NPT taken into considerations.
Who is asking the question? Sorry.
Andrews.
Oh, Hendrix. Oh, my friend. That's beautiful. So why
Yes, that's why I
calculating
said your friend.
workers' pay is MPT? Hendrix, if you employed Christabel to come and let's take it as to come and decorate your house, and she ends up breaking your television, what are you going to do? Hendrix, over to you. Hendrix, can you hear me? Oh God, your network, Hendrix. I wonder if you hear me. Please, can anyone confirm if you can hear me?
Yes, sir.
Yes,
We
sir.
can hear you.
We can hear
Okay.
you clearly, sir.
I cannot destroy his television, sir.
And it's not you I'm talking about. I'm talking about another Christabel. Hendrix, please confirm you can hear me. Okay, so let me just continue. If he hears me, let me just answer his question. So it's based on the contract, what the contract states, right? So there are some MPTs. For instance, now, you're drilling, and then let me see, which clear example can I give right now? your drilling, and then the RSS that is meant to help you to make the hole fails. If the RSS fails, yes, there's an MPT. The MPT is that the RSS fails and is the directional driller that provided the RSS, rotary steerable system, right? For that, what can you do then? You find them, you tell them, you see, for this day till we run back in hole and continue drilling, I'm not going to pay you. If I spend 1 day or 2 days to pull out of hole and run back in hole, I'm not going to pay you money until you go back to that depth that you are in. That's the punishment. So by the time you say you're not paying them, paying them as a company, they also go and find a way to also make the personnel on location pay for it. In what way? By their review. Most times, if you come back successful, companies give you good bonuses as a service company. So when you come back bad, you'll not get that bonus. Sometimes they'll be scared to deploy you to the field. You'll no longer be going to field. Not like they'll not pay your salary, but by the time they stop taking you to location because you're underperforming or don't give you those little bonuses, that's a way of punishing you. But you not paying that in directional drilling, there's what they call rig spread. It's not that directional drilling that you didn't pay, but other service people that were there for those 2 days that they are trying to run back in hole, you still have to pay other people. So that's why MPT is not a good thing. I don't know if I answered your question. Otherwise, I hand over to Christabel to help me and answer it. Thank you.
Okay, since my name is suiting you very well, okay, I'll take over now. So please, do we have Mr. Jibola with us now? Okay, since he's not here. So, sir,
Okay,
please, we don't know if we can be able to reach out to you for those of them that still have their questions that they unattended to.
Under one condition, if you provide dinner for all of them, no wahala. But you can you can reach out, drop your questions through Tina or through Isaac. And sorry, Israel. I think I've not heard Israel's voice. I don't know if he's in this meeting. You can reach out through Tina or through Israel. They can reach out to me. I know them personally. I don't know if I know any other person here. Oh, Santos. I know. Is this Santos? Tina, is this
Yes,
yeah,
Santos?
yes,
yes,
it
sir,
is.
this is Santos.
Boogeyman. Boogeyman. So you did here. No wahala. Well done.
Yes, sir.
Please, this is not a family reunion. No. So quickly, we'll be
All
going
these
to the.
PDP members off your mic. Let APC rule.
So we'll be taking our closing. Thank you very much, Engineer Ogoshuku. We actually did learn a lot. Thank you very much. I learned some terms like piling, casing, tallying, and so on. Thank you very much. We really do appreciate your lecture. So we are rounding up now. Thank you, everybody, for your time and everything. So we'll call on the chairman of IEDC PTI chapter for the closing remarks.
Okay, please, sorry, before the closing remarks, the announcement is coming up, please.
Okay, for the announcement.
Okay, good evening, everyone, once again. I will be taking the
Good evening.
announcement in place of Jibola. I cannot really. Okay, I say. The worry section, SPE worries Nigerian section, will be having the student committee will be having a meeting this Friday. I can't see the slide again. We'll be having a meeting this Friday by 5 p.m., which presents fueling the future, innovation, digitalization, and sustainability in petroleum engineering. And we hope that you would join us for the meeting. Just as you have learned today, there are so many things to learn that day as well.
Okay, is that all for the announcement? Miss Tina.
Can you hear me?
Okay. Is that all for the
Uh,
announcement?
no, sorry. And we'll also be having our general meeting on the 19th of this month, which is, I think, next week, Saturday. Yes, we'll be having, and the venue is Conference Center, PTI Conference Center, 10 a.m. And that will be all for the announcement.
All right, thank you very much. So we'll be taking our closing remarks by the chairman, Mr. Solomon. Please, over to you.
Okay, good evening. Can you all hear me?
We can hear you.
We can hear you.
Okay, thank you very much, Engineer Ugochukwu. We want to extend our thanks to you, IEDC and SPE, on your explanations, beginning with the definitions of what is drilling, types of drilling, the drilling program, and monitoring that is very, very, very helpful for us in the oil industry, and understanding key terms such as knowing why we use water-based mud in drilling the upper section, and also knowing and understanding parameters in monitoring, such as blow per feet. So thank you very much, and also using your incredible analogies to explain some complex concepts in drilling. So, sir, we say thank you very much, and we hope to hear from you again in any program we are having. Thank you very much, sir, and thank you very much, Christabel, because Christabel is the star of the show. So at this juncture, we call to the of the end of this program. So good night, everyone. Thank you very much for coming.
Thank you.
Okay,
Have a
thank
nice
you,
day, everyone.
everybody. Thank you, everybody that has joined us. Thank you so much for your time and everything. Thank you.
Buy me Capri Sun, I beg.
I'm pretty sure
Christabel,
those
they
of
say
us
we
that
dey
doesn't
meeting.
know the meaning of IADC and SP. IADC is the International Association of Drilling Contractors, while SP Society of Petroleum Engineers. So that's all for the program. Good night, everybody.
Mm.